Okay, let's have a go at exercise 604, so the roots and coefficients of polynomial equations. So question number one, we're given quadratic equations and we need to find the sum and the product of the roots. So question number one, x squared minus 2x plus 8 equals 0. We're going to say this is minus, this is plus. So alpha plus beta, which is the sum of the roots, is going to equal minus b over a, or minus 2 over 1, so 2. Alpha beta, the product of the roots, is going to be 8 over 1, or 8. Part B, 3x squared plus 6x minus 2. Alpha plus beta is going to be minus b on a, so minus 6 on 3, which is minus 2. And alpha beta is going to be, here we go, minus plus, minus 2 on 3. Part C, x squared plus 7x plus 1. Alpha plus beta is going to be minus plus, so minus 7, and alpha beta is going to be 1 over 1. Part D, 4x squared minus 9x minus 12. Alpha beta is going to be minus 9, 9 on 4, and alpha beta is going to be minus 12 on 4, or minus 3. Part E, 5x squared plus 15x. I'm going to write plus 0 at the end like this. So alpha plus beta is going to be minus b on a, or minus 15 on 5, which is minus 3. Now alpha beta is going to be 0 on 5, or 0, because c is 0. So question number 2, we've got quadratic equations. So we have x cubed plus x squared minus 2x plus 8. So our alpha plus beta plus gamma, I'm going to say minus plus minus is equal to minus 1 on 1. Alpha beta, I might just say sum of the roots 2 at a time, or just part 2. The sum of the roots 2 at a time is going to be minus 2 on 1. And part 3 is minus 8. So minus d on a, which is minus 8 on 1. Okay. Part B, we have x cubed minus 3x squared plus 5x minus 2. Part 1, the sum of our roots is going to be minus b on a, so minus plus minus, which is going to be positive 3. Part 2 is going to be 5. Part 3, the product of the roots, is going to be minus 2, which is 2. Okay, part C, 2x cubed minus x squared plus 6x plus 2. I write minus plus minus. So part 1, the product, the sum of our roots is going to be minus 1 on 2, so 1 over 2. Part 2, it's going to be positive 6 on 2, which is 3. And part 3, it's going to be negative 2 on 2, which is minus 1. Okay, part 2, minus x cubed minus 3x squared minus 11. We have part 1, the sum of the roots is minus 3. I might, in here, I've just realized we have no x term. So I'm going to write plus 0x. So the sum of our roots is minus b on a, which is going to be minus 3 on minus 1, which is negative 3. Part 2 is just 0. So 0, c on a, which is 0 on minus 1, which is 0. And part 3, the product of the roots is going to be minus d on a, which is going to be minus 11 on minus 1, which is minus 11. And part E, x cubed plus 7x minus 3. I'm going to write plus 0x squared here. So, and I'm going to say this is minus, this is plus, this is minus. So the sum of the roots, part 1, is going to be 0. Part 2, the product, the sum of the roots 2 at a time is going to be 7 on 1, or 7. And part 3, we're going to have minus 3 on 1 for the product of the roots, or 3. Okay, question number 3. We've got quadratic equations, so we've got alpha, beta, gamma, and delta. So question number 1, we've got x to the power of 4 plus 2x cubed minus x squared plus minus x plus 5. So we have minus plus minus plus. So the sum of the roots is going to be minus 2. The sum of the roots 2 at a time is going to be minus 1 on 1. The sum of the roots 3 at a time is going to be minus 1 on 1, which is 1. And part 4, the product of the roots is going to be positive 5 on 1. Part B, x to the power of 4 minus x cubed minus 3x squared plus 2x minus 7. The sum of the roots, first of all, minus plus minus plus, is going to be minus 1 on 1, which is positive 1. Part 2, the sum of the roots 2 at a time is going to be minus 3, so minus 3 on 1. Part 4 is going to be minus 2 on 1, or minus, part 3, and then part 4, the product of the roots. Part 3 was the sum of the roots 3 at a time, but the product of the roots is going to be positive, but it's minus, so minus 7 on 1. What are we up to? C. Minus x to the power of 4 plus x cubed plus 3x squared minus 2x plus 4 minus plus minus plus. So part 1, the sum of the roots is going to be minus 1 on minus 1, because there's a minus here. So 1. Part 2 is going to be 3 on minus 1, which is minus 3. Part 3, the sum of the roots 3 at a time is going to be minus 2 on minus 1, which is minus 2. And part 4, the product of the roots is 4 on minus 1, which is minus 4. Okay, part D. 2x to the power of 4 minus 2x cubed minus 4x squared plus 3x minus 2 equals 0. Rightio, so we've got minus plus minus plus. So part 1, the sum of the roots is minus 2 on 2. So it's going to be positive 2 on 2, which is 1. Part 2 is going to be minus 4 on 2, which is minus 2. Part 3 is going to be minus 3 on 2. Part 4, looks different. Oh, and part 4 is going to be, sorry, I had a mind blank. Part 4 is going to be positive minus 2 on 2, which is minus 1. Okay, and last one for this question. 2x to the power of 4 minus 12x cubed, right, plus 0x squared plus 0x plus 7. So part 1, the sum of the roots is going to be, well, minus plus minus plus, so it's going to be minus 12 on 2, so positive 12 on 2, which is 6. Part 2 is going to be 0. Part 3 is going to be 0, and part 4 is going to be 7 on 2. Okay, question number 4 is where they start to get interesting, so we have to manipulate some expressions. So we have x squared minus 5x minus 5 equals 0. So part 1, nice and easy, that's the sum of the roots. So we write minus plus is going to be, I've lost it, minus 5, which is positive 5 over 1. Part B, so that was A, part B is the product of the roots. So I might write this here, alpha plus beta equals 5. The product of the roots is going to be minus 5. Part C, we did a similar example like this in class, 1 on alpha plus 1 on beta. Well, we can't touch this at all because we don't have alpha beta or alpha times beta in this. So we need to make a common denominator, and it's going to be alpha beta, and then on the top alpha, it's going to be beta plus alpha actually. And we already know what those two things are. We know alpha plus beta is 5, and we know alpha beta is minus 5, so the answer is minus 1. Okay. Part D I purposely didn't show you in class because I wanted you to have a go at finding it out yourself. alpha squared plus beta squared. Important to note that this is not the same as alpha plus beta squared. But we do know if I got alpha plus beta squared, let's see what I would get. So, rubbing this out, alpha plus beta, all squared, is alpha squared plus 2 alpha beta plus beta squared. So, alpha squared plus beta squared is the same as saying, well, we don't like this in the middle. This on over here, we've got alpha squared and beta squared. We wanted that, but we don't like that thing in the middle. So we can say that alpha squared plus beta squared is the same as saying alpha plus beta squared minus 2 alpha beta. So we're taking that away. So we already know alpha plus beta squared is, alpha plus beta is 5. So 5 squared. Take away 2, and we figured out alpha beta was minus 5. So 25 plus 10, which is 35. Okay. Question number 5. So we've got the cubic equation. The cubic equation 2x cubed plus 5x squared minus x minus 3 equals 0. So the first 3 are nice and easy. So alpha, beta, gamma. I might do it in order actually. It's a bit weird, that order. Let's do part C first. Alpha plus beta plus gamma. We know we've got minus plus minus, so it's going to be minus 5 on 2. We'll do part D next. Part B next. So alpha beta plus alpha gamma plus beta gamma is just the sum of the roots 2 at a time, which we know is minus c on a, so that's going to be plus minus 1 on 2, so minus a half. And part A, alpha beta gamma, is minus 3 on 2, which is 3 on 2. So part D, we did that in class already, quite a similar one. We know that we can make 1 on alpha plus 1 on beta plus 1 on gamma. We can make that alpha plus beta plus gamma on alpha beta gamma. So we know alpha plus beta plus gamma is minus 5 on 2, and we know alpha beta gamma is 3 on 2. Now if you do that, you'll get minus 5 on 3. Okay, part E. Let me quickly expand that. So we've got alpha plus 1, beta plus 1, and gamma plus 1. So that's going to be, let's expand the first set of brackets, alpha beta plus alpha plus beta plus 1 times by gamma plus 1. So then we have alpha beta gamma plus alpha gamma plus beta gamma plus gamma plus alpha beta plus I've lost myself, plus alpha plus beta plus 1. Rearranging that, we can rewrite this as alpha beta gamma plus alpha gamma plus beta gamma plus beta alpha plus alpha plus beta plus gamma plus 1. So we know alpha beta gamma, we figured alpha beta gamma to be 3 on 2. We figured the sum of the roots 2 at a time to be minus 1 on 2. And we figured out the sum of the roots to be minus 5 on 2. And we have plus 1. So that's going to be 3 minus 6 minus 3 on 2 plus 1. Which is, I think it's minus 1 on 2. I don't actually have a calculator on me, but I think that's it. Okay, question number 6. So we've got a quartic equation. So we've got x to the power of 4 minus 2x cubed plus 0x squared plus 5x minus 3, and that equals 0. Okay, question number 1, we need to find alpha, beta, gamma, delta. Well, that's just the product of the roots, so I'm going to write minus, plus, minus, plus. Another reason we write our plus 0x squared is because if we didn't, it would mess up our minus, plus thingy. So we've got plus minus 3, so minus 3 on 1. So that's part A. Part B, we're finding the sum of the roots 3 at a time, which is this one here. So that's minus 5 on 1. And part C, hopefully you guys should be okay with realizing that that is just going to become, on the bottom, alpha, beta, gamma, delta. And on the top, it's going to be alpha, beta, plus, sorry, no it's not. Alpha, beta, gamma, plus alpha, beta, delta, plus beta, gamma, delta, plus beta, gamma, delta, alpha, beta, gamma, delta, beta, alpha. Sorry, I forgot. There's one that I've forgotten. Alpha, gamma, delta. Alpha, gamma, delta. That's better. Okay. Now we just figured out the top thing was minus. Oh, the top thing was minus 5. We just figured that out, and the bottom thing was minus 3. So the answer is 5 on 3. Okay. Number 7. 1 root of the equation x squared minus 3x plus k minus 2 is 4. Okay, I might put that k minus 2 in brackets. And we have to find the value of k. So we know we've got in the quadratic equation, we've got a and b, so a, b, and c. Our c term is k minus 2, not just k or not just minus 2. So the sum of the roots alpha plus beta, we've got minus plus, alpha plus beta is minus minus 3, which is 3. And the product of the roots, alpha beta, is k minus 2 over 1. So we know one of the roots is minus 4. So we can say that this is alpha minus 4 equals 3. So that would make alpha 7. So we also can then substitute alpha into our second equation. So 7 beta equals k. No, sorry, that's wrong. We've just figured out alpha was 7, but we've also replaced beta with minus 4. So 7 times by minus 4 is equal to k minus 2. So 7 times 4 is minus 28 equals k minus 2. So k is equal to minus 26. Okay, number 8. 1 root of x cubed minus 5x squared minus x plus 21 equals 0 is 3. Find the sum and the product of the other two roots. So we know alpha plus beta plus gamma, we've got minus plus minus, is equal to minus minus 5, which is 5. We know that alpha beta plus alpha gamma plus beta gamma is equal to positive minus 1 on 1, so minus 1, and alpha beta gamma is equal to minus 21 on 1. So we're told that one of the roots is 3. So from up here we can say that 3 plus beta plus gamma equals 5. So beta plus gamma is 2. So we've already answered half the question. It said find the sum and the product of the other roots. So that's the sum of the other roots. And if we replace alpha with 3, we have 3 beta gamma is minus 21, which means beta gamma is minus 7. So that's our answer there. I think we did this one as an example, actually. Okay, number 9. We've got the equation p of x is equal to 2x cubed minus 7x squared plus 4x plus 1 is 0. we're told that p of x is, when p of x is 0, it has a 0 as 1. Find the sum of the product of the other roots. So that's just a fancy way of saying one of the zeros is 1. So we say minus plus minus. We know alpha plus beta plus gamma equals minus minus 7 on 2, so 7 on 2. And we also know that one of the roots is 1. So 1 plus beta plus gamma equals 7 on 2, which would mean that beta plus gamma, 7 on 2 minus 1, I think it's, 5 on 2. So we've done that. That's the sum of the other roots. And the product, well, we know alpha, beta, gamma is equal to minus minus 1 on 2. That's from up here. Minus 1 on 2. We know one of the roots is 1. So beta gamma, we've got 1 times beta gamma, is minus 1 on 2. So the product of the other roots, beta gamma, is simply minus 1 on 2. That was fun. Okay, are we done? Yeah, we're done. This is a long one. Find the value of k if the quadratic equation x squared minus k plus 2x plus k plus 1 equals 0. Okay, I haven't seen these types of questions in like 4 years, so bear with me. I should be able to get them. So we're told so this is a quadratic equation, so let's go minus, that's a minus and that's a plus. So we're told it has equal roots. So instead of having alpha plus beta, we're going to say alpha plus alpha. And that's equal to minus minus k plus 2 on 1, so k plus 2. So 2 alpha equals k plus 2. And we know that alpha squared, the product of the roots, alpha times alpha squared is equal to k plus 1. And what do we have to do? Find the value of k. Rightio, so from this equation we can deduce that alpha is equal to k plus 2 on 2, which would mean alpha squared is k plus 2 on 2 squared. So, equating these two equations, this one and this one, we can say k plus 1 equals k plus 2 on 2 all squared. I'm going to expand that. K plus 1 is equal to k squared plus 4k plus 4 on 4. Bring the 4 to the other side. 4k plus 4 equals k squared plus 4k plus 4. Making everything 0. 0 is k squared plus... The 4k, they all cancel, so that means k is 0. That was nice. Okay. One of the roots is equal to 5. Okay, so instead of alpha plus beta, we're going to have 5 plus beta, and that's going to equal k plus 2. And instead of alpha beta, we're going to have 5 beta equals k plus 1. Yep, okay. Hopefully this is a bit easier. So beta from this is going to be k minus 3. So 5k minus 3 equals k plus 1. So 5k minus 15 equals k plus 1. Bringing that over to there and that over to there. 4k is 16, so k is 4. Bam. Consecutive roots. Okay, these are where they get fun. So instead of alpha and beta, consecutive means one after the other. So we're going to have alpha and alpha plus 1. So we're going to say the sum of the roots is alpha plus 1, and that equals k plus 2. And the product is alpha times alpha plus 1, and that's equal to Sorry, that's k plus 1. No, that is k plus 2, and this one's k plus 1. So from this, we can deduce that alpha is equal to k plus 1 on 2. I think, yep, so you minus a 1 and then divide by 2. Yep, k plus 1 on 2. So, substituting that into our other equation, not going to be the prettiest, sadly. I'm going to have k plus 1 on 2 squared plus k plus 1 on 2 equals k plus 1. So we're going to have k squared plus 2k plus 1 on 4 plus k plus 1 on 2 equals k plus 1. Then if we bring the 4 up to there, and also, so we're going to have k squared plus 2k plus 1 plus 2k plus 1 on, oops, let's get rid of u, on 4 equals k plus 1. Bringing the 4 up to there, we're going to have k squared plus 2k plus 1 plus 2k plus 2 equals 4k plus 4. Simplifying both sides, we've got k squared plus 4k plus 3 equals 4k plus 4. The 4k's cancel, and we have k squared plus 3 equals 4, which means k squared is 1, which means k is plus or minus 1. One root double the other. So instead of alpha and beta, we're going to have alpha and 2 alpha. So the sum is going to be alpha plus 2 alpha, which is 3 alpha, but it's going to equal k plus 2. So 3 alpha equals k plus 2. The product of the roots is going to be alpha times 2 alpha, which is 2 alpha squared, and that's equal to k plus 1. So sadly, what we're going to have to do is say that alpha is equal to k plus 2 all on 3, which means 2 alpha squared is going to be 2 times by k plus 2 on 3 squared, and that's equal to k plus 1. So expanding that, we're going to have 2 times by, let's say 2 on 9, times by k squared plus 4k plus, and the 9, sorry, is because 3 squared is 9, plus 4, and that equals k plus 1. So bringing the 9 to the other side and expanding, we have 2k squared plus 8k plus 8 equals 9k plus 9. So we have 2k squared minus k minus 1 equals 0. Now I don't have a calculator, so hopefully you solve that. Let's think, can we let me have a go at factorizing this. So 2k and k, 1, 1, 2, 1, minus here. Okay. Do your best at factorizing that. I use this method sometimes. I know you've been taught lots of different methods. So this factorizes to be 2k plus 1, k minus 1, and that equals 0, which means k is equal to minus 1 on 2, or 1. I would solve that better and show you, but I don't have a calculator, actually. It's left it at home. And reciprocal roots, this is another thing. The definition of reciprocal, instead of alpha and beta, we're going to have alpha and 1 on alpha. So the sum is going to be alpha plus 1 on alpha, and that's equal to k plus 2. And the product, this is where they get interesting with the reciprocal, the product is alpha times by 1 on alpha, which is 1. So they just go away, which means 1 is k plus 1, which means k is 0. Okay, 11. And you could probably solve this, maybe, and also get 0. But you just need the product of the roots generally when you have reciprocal ones. Okay, number 11, we've got 2 roots. So we've got a cubic equation, which means we have a maximum of 3 roots, so x cubed. Actually, we did this one in class. I'm going to skip to 12. Show that if 1 is show that 1 is a 0 of the polynomial. So you just need to show that p of 1 is 0. I'm not going to do that because I don't have a calculator. So we are told that alpha, beta, and gamma are the other 3 zeros. Find the value of alpha plus beta plus gamma and alpha, beta, gamma. So we've got the equation x to the power of 4 minus 2x cubed plus 0x squared plus 7x minus 6. So we know that 1 is one of the roots. So we've got alpha plus beta plus gamma, and we're told that the other 0 is 1. So plus 1 minus plus minus plus. So that's going to equal minus 2 on 1, which is 2. So alpha plus beta plus gamma is 1. And the product, we don't need to find the sum of the roots 2 at a time. The product of the roots is alpha, beta, gamma times 1, which is positive minus 6 on 1, so minus 6. So alpha, beta, gamma is just minus 6. Number 13. If x is a double root of ax to the power of 4 minus 2x cubed minus 0, say plus 0x squared minus 8x plus 16 equals 0. Find the value of a and the sum of the other 2 roots. Right, so I'm going to say minus plus minus plus. We know x is 2 is a double root, so that means 2 of our roots are 2. So our sum is going to be 2 plus alpha plus beta. And that's equal to minus 2 on a. So 4 plus alpha plus beta is equal to 2 on a. What are we doing in the question? Finding the value of a and the sum of the other 2 roots. Okay, let's do the sum of the roots 2 at a time. So normally it would be alpha beta plus alpha gamma plus beta gamma. I think. Oh no, this is a quartic equation. It's quite a lot we need to do here then. So let's do the sum of the roots 2 at a time. So normally it would be alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. Yep, that's right, that's all of them. And that equals 0. So let's replace, so alpha and beta are the same. We know that the other 2, so let's say gamma is 2 and delta is 2. So plus 2 alpha plus 2 alpha plus 2 beta plus 2 beta plus 4 equals 0. So alpha beta plus 4 alpha plus 4 beta plus 4 is 0. That's interesting. I might take out a factor of 4, so alpha beta plus 4 alpha plus beta plus 4 is 0. And that's something we know there. That's something we know there. Let's do the sum of the roots 3 at a time. Alpha beta gamma plus alpha beta delta plus beta gamma delta plus alpha gamma delta, I think. Alpha gamma delta. And that's equal to minus 8 on A, so 8 on A. Now we know that gamma is 2 and delta is 2. So alpha beta, so it's going to be 2 alpha beta plus 2 alpha beta plus beta times 2, so 4 beta plus 4 alpha, and that's 8 on A. So we've got 4 alpha beta plus 4 alpha plus beta is equal to 8 on A. Okay, that's something else we know. And the product, alpha beta gamma delta, is alpha beta times 2, which is 4. So 4 alpha beta is equal to 16 on A. So that's quite helpful now, because we know alpha beta is equal to 4, if we divide the 4 over, it's 4 on A. So that's important, because we can now do some substitution. So if I call this equation 1, and this equation 2, and this equation 3, and this identity 4, let's substitute what we know into number 2. So we know that 2 is alpha beta plus 4, alpha plus beta plus 4 is 0. We know alpha beta is 4 on A. So, sorry, I might say sub 4 into 2. So we have 4 on A plus 4 alpha plus beta plus 4 equals 0. Now, we also know from equation 1 that alpha plus beta is 2 on A minus 4. I'm going to call that identity 5. So I'm going to sub 5, and I'm going to call this equation 6 into 6. So 4 on A plus 4. We are told that it's equal to 2 on A minus 4 plus 4 is equal to 0. So 4 on A plus 8 on A minus 16 plus 4 is equal to 0. So 12 on A is equal to minus 16 plus 4 is minus 12. So 12 on A is 12. Oh, which means A is 1. That's cute. A is 1. Is that all we had to do? I think we had to do something else. And find the sum of the other two roots. Oh, so we know that alpha plus beta plus 4 was equal to 2 on A. We know A is 1, so alpha plus beta plus 4 is equal to 2 on 1, which is 2. So alpha plus beta is minus 2. Hope that's right. That was a very long question. Alright, number 14. Can't stop now. X cubed minus px squared minus qx plus 30 equals 0. So two of the roots, we've got 3 and 5. Find the other root. So minus plus minus. So we know that we've got 3 and 5. So let's say we've got alpha, we'll say alpha plus 3 plus 5 equals minus minus p. So alpha plus 8 equals p. That's something we've just discovered. We know that alpha beta plus alpha gamma plus beta gamma, that looks like a p, plus beta gamma is positive minus q. But we know that beta and gamma are equal to, beta is 5 and gamma is, no, we define beta as 3 and gamma is 5. So 5 alpha plus, no, sorry, 3 alpha plus 5 alpha plus 15 equals minus q. So what do we have? 8. That should be an alpha. Alpha plus 15 equals minus q. All right. And we know that hopefully the product is going to help us, because the product, the coefficient, sorry, the constant term is just a whole number. So alpha times by 3 times 5, so 15 alpha is equal to minus 30 on 1. So alpha is equal to minus 2. Part B, find P and Q. So let's just use those identities. We know that alpha plus 8 equals P. So minus 2 plus 8 is P. So P is 6. And the next part, we know that 8 alpha plus 15 is minus Q. So 8 times minus 2, minus 16 plus 15 is minus Q. Minus 16 plus 15 is minus 1, so Q is positive 1. Okay. Hopefully these don't take too long. Okay. The sum of the two roots of x to the power of 4, sum of two of the roots of x to the power of 4 plus x cubed plus 7x squared plus 14x minus 1 is 4. So let's say normally we'd have alpha plus beta plus gamma plus delta, and that would be minus plus minus plus. That would normally be minus 1. But we know two of them add together to equal 4. So we're just going to get rid of two of them and put a 4 in place. So we just have to find the sum of the other two. Oh, that was easy. So alpha plus beta is minus 5. Surely that's not that easy. Let me think about that again. The sum of two of the roots is 4. Okay, no, that's easy. Number 17. Find the roots of x cubed minus 3x squared plus 4 equals 0, given that two of the roots are equal. So two of them the same. So instead of alpha, beta, gamma, we're going to have alpha, alpha, beta, for example. So let's put in our plus 0x first. So minus plus minus. So we're going to have alpha plus beta. Remember, it's a cubic equation, so we can only have 3. And we know that's minus 3 on 1. So 2 alpha plus beta is 3. We know normally we would have alpha beta plus alpha gamma plus beta gamma, and that's normally going to equal 0 in this equation. But we know we don't have three unique roots. We've got two of the roots being the same. So this is going to be alpha squared. This is going to be plus alpha beta, and this is going to be plus alpha beta again. So we've got alpha squared plus 2 alpha beta equals 0. And finally, we're going to have 2 alpha squared beta equals minus 4. Is this the one we did in class? I'm not sure. Alright, so let's do this again. I want to try a different way than I did it in class. What is our goal of this question? Given that 2 of the roots are equal. Okay, so we can deduce that beta equals 3 minus 2 alpha. Let's substitute that into this one. So alpha squared plus 2 alpha, 3 minus 2 alpha, equals 0. So alpha squared plus 6 alpha minus 4 alpha squared is 0. So, oh dear, minus 2 alpha squared plus 6 alpha equals 0. Oh, we're going to get the same answer as last time, but so much easier. So we can rearrange and say 6 alpha equals 2 alpha squared. We can cancel out an alpha from each side. So we're going to have 6 is equal to 2 alpha, which means alpha is 3 on 2. Oh, I think actually Toby suggested that. So well done, Toby. You got that quicker. But I guess the other way was still fun. So we've done, I think that's all we had to do. Oh, so alpha is 3 on 2. And we know that beta equals 3 minus 2 alpha. So 3 minus 3 times 3 on 2, which is 3 minus 9 on 2, which is 18, whatever that is. I don't have a calculator, but that would be the answer. Okay, 18. Solve 2x cubed minus 4x squared minus 3x plus 1 equals 0. If the sum of 2 of the roots is 0. Okay. Oh, and we have to solve. Oh, that's different. So we just need we have to find the solutions. So, how did that get there? There we go. So let's go minus plus minus. So we know the sum of 2 of its roots is 0. So we're just going to have alpha plus beta, and the other 2 is just plus 0. And that's minus minus 4 on 12, so 4 on 12. So alpha plus beta equals 4 on 12, which is what, 1/3? What else can we do? So alpha plus beta is 1/3. Okay, we can do the product of the roots, I guess. Given that the sum of 2 of its roots is 0. Okay, well we normally have alpha beta plus alpha gamma plus beta gamma plus alpha plus, is that it? Alpha beta plus alpha gamma plus beta gamma. Okay, I think that's all of them. And that's equal to minus 3 on 12, which is 1/4. So minus 1/4. And the product, alpha, beta, gamma, is equal to minus 1 on 12. So I'm just thinking of how we can solve this. the sum of two of its roots. Oh, I'm stupid. I need to start this question again. Sorry. Okay, so this is a cubic equation, which means it only has two roots. So instead of alpha plus beta plus gamma, if two of them are 0, so we're just going to have alpha and the other two are going to be 0. So alpha plus 0 is equal to 4 on 12. So alpha is equal to 1 on 3. Now that would mean, what it wants you to do is polynomial divide. So, if alpha is 1 on 3, well that means 3 alpha minus 1 equals 0. So we're going to do some polynomial division here. So 3 alpha minus 1, I'm going to do my best without a calculator. 12x cubed minus 4x squared minus 3x plus 1. Let's, just to make it a bit simpler, change that alpha to an x. That doesn't really affect anything. We can do that. So let's do some polynomial division. This is going to be 4x squared. So that's going to be 12x cubed minus 4x squared. It's going to be 0. So minus 3x. So that's plus 1. So then 3x. Let's bring down the plus 1. So 3x minus 1. What's gone wrong? 0 minus 3. Oh, that's going to be a minus 1 here. A minus, so then minus 3x plus 1. And that's 0. So this factorizes to be 3x minus 1. 4x squared minus 1 equals 0. So then x is 1 on 3, or 4x squared minus 1 is 0, which would make x plus or minus a half. Okay, sorry for getting confused, but that makes a lot more sense now. Okay, sorry, I got interrupted and had to go and do something. So let's have a go at 19. So we've got 6x to the power of 4 plus 5x cubed minus 24x squared minus 15x plus 18. We need to find the sum of the roots if two of its roots are equal. Sorry, sum of two of its roots is 0. Okay, so let's consider two of its roots, alpha plus beta, and we're told this sum is 0. That makes alpha equal to minus beta. Let's consider the other two roots, gamma plus delta. Well, that's going to be minus plus minus plus. It's just going to be the sum of the roots one at a time, so it's minus 5. Sorry, minus 5 on 6. Okay, now let's consider the sum of the roots 2 at a time, so that's something we've noticed. Normally it would be alpha beta plus alpha gamma plus beta gamma plus beta alpha gamma plus 1, 2, 3, 4 plus beta delta plus delta gamma, and that normally is going to be minus 24 on 6. But we know that alpha is minus beta. So if alpha is minus beta, this is going to be minus alpha squared plus alpha delta minus alpha gamma plus alpha gamma minus alpha delta plus delta gamma, and that's equal to minus 4. So what we've got is this will cancel with that, and that will cancel with that. So we've got minus alpha squared plus gamma delta equals minus 4. Right. Let's consider the roots 3 at a time. So normally it's alpha, beta, gamma plus alpha, beta, delta plus beta, gamma, delta plus alpha, gamma, delta. And that in this case is equal to positive 15 on 6. But we know alpha is equal to minus beta, or sorry, beta's minus alpha, same thing. So we've got minus alpha squared gamma minus alpha squared delta minus alpha delta gamma plus alpha delta gamma. So they die, and we have minus alpha squared gamma minus alpha squared delta equals 15 on 6, which is minus alpha squared gamma minus delta equals 15 on 6. Right, this is a lot. Let's do the product of the roots alpha, beta, gamma, delta. And that's equal to, in this case, 18 on 6, which is 3. We know beta's minus alpha squared, so it's going to be minus alpha squared gamma delta is 3. Right. We know already, I feel like I've done something wrong. Oh, that's a plus there. Sorry. If we take out this minus, then this has to be a plus. We know that from up here, if I call this 1, and this 2, and this 3, and this 4, we know that gamma plus delta is minus 5 on 6, so minus alpha squared, I might write what I'm doing, so sub 1 into 3 minus alpha squared. We know gamma plus delta is minus 5 on 6, and that's equal to 15 on 6. That can't, no, yep, that cancels, so we've got, and that divides over to there to give 3, so alpha squared is 3, which would make alpha plus or minus the square root of 3. Have we done? What else did we have to do? Oh, we're solving it. Okay, so we know one of the roots. We've got two of the roots is plus and minus root 3. So we need to find gamma. We've got alpha. We need gamma and delta. So we've got to find them all, I guess. So using our first our second identity, let's have a go at getting some things, because we know what alpha is now. So we know that minus alpha squared plus gamma delta equals minus 4, which would mean, well, alpha squared is 3. So this is going to be minus 3 plus gamma delta equals minus 4. So gamma delta is equal to 1. Minus 1. Now, that potentially helps us. What can we do with that? So that's something else we know. I guess we can say that delta, or gamma, is minus 1 on delta, and then substituting in that into our equation, the first one we realized, gamma plus delta is minus 5 on 6. we can say that minus 1 on delta plus delta is minus 5 on 6. Timesing the 6 up, we've got minus 6 on delta plus delta equals minus 5. Timesing up the delta, minus 6 plus delta squared equals minus 5 delta. So delta squared plus 5 delta minus 6 equals 0. Oh, I know what I've done wrong. If I times the 6 up, I need to put a 6 here as well. So that's a 6, and that's a 6 there. So 6 delta squared plus 5 delta minus 6 is 0. We can factorize that to be 3 delta minus 2. 2 delta plus 3 equals 0, which means that delta is 2 on 3, or minus 3 on 2. So therefore, we've got some delta solutions. We need to find gamma. So we know that gamma is equal to minus 1 on delta. So we know that gamma is equal to either minus 1 on 2 on 3 or minus 1 on minus 3 on 2, which is gamma is equal to minus 3 on 2 or positive 2 on 3. Okay, those are our solutions. So therefore we've just solved it. So we've just found expressions for gamma, alpha, and delta, which are our solutions. Remember, alpha, beta, gamma, delta are just our solutions to the equation. So we've got plus or minus root 3. We've got minus 3 on 2 and 2 on 3. Note that these appeared twice, but there's no point writing them twice as our solutions. Alright, that was fun. Number 20. We've got x cubed plus mx squared minus 3x minus 18 equals 0 are equal and rational. Okay, we know that 2 of the roots are equal and we know the roots are rational. Now, rational means the roots can be expressed as fractions. So, let's have a go. We've got minus plus minus, so we know 2 of the roots are equal, so let's say alpha plus beta is equal to minus m. Normally, we would have alpha beta plus alpha gamma plus beta gamma, and that would be equal to 3, or minus 3. But instead, we're going to have alpha squared plus alpha beta plus alpha beta equals minus 3. So alpha squared plus 2 alpha beta is minus 3. So that's one thing we know. That's another thing we know. We also know 2 of the roots are equal and one of them's not the same. So this product is going to be alpha times beta, or alpha squared beta. And we're told that's equal to minus 18, which is 18, which means beta is 18 on alpha squared. We can substitute that into here. So let's call this 1, substitute beta equals 18 on alpha squared into 1. So alpha squared plus 2 alpha times by 18 on alpha squared, and that's equal to minus 3. So that cancels, so alpha squared plus plus 36 on alpha equals minus 3. Timesing the alpha up, we're going to have alpha cubed plus 36 equals minus 3 alpha. So alpha cubed plus 3 alpha plus 36 equals 0. Okay, we need to solve this equation. We need to do that by polynomial division. So we need to find a factor that goes into it. Minus 3 will work. So p of minus 3. So that means alpha plus 3 is a factor. So let's divide by alpha plus 3. So alpha cubed plus 0 alpha squared plus 3 alpha plus 36. So alpha squared, alpha cubed plus 3 alpha squared is going to be minus 3 alpha squared plus 3 alpha. That's minus 3 alpha minus 3 alpha squared minus 9 alpha. It's going to be 6 alpha plus 36 plus 6. 6 alpha. Oh, what's gone wrong? Oh, so that's not going to be 36, and that is because 3 minus 9 is 12, so 12 alpha plus 36, so that's going to be plus 12, so 12 alpha plus 36, and that's 0. So our equation can be written as alpha plus 3, alpha squared minus 3 alpha plus 12. Right, so if we look at the discriminant of this, so I'm going to see, can I factorize this? I don't think I can. Is equal to b squared minus 4ac, which is going to be 9 minus 4 times by 12, which is definitely less than 0, so this can't be solved. So we only have one solution. So remember, when our discriminant's less than 0, we can't solve. So alpha is minus 3. We know that beta is 18 on alpha squared. So beta equals 18 on alpha squared, which is 18 on minus 3 squared, which is 2. So alpha is minus 3, beta is 2. And we had to find m, I think. How can we do that? Oh, nice. So we can just use our first identity. So alpha plus beta is minus m. So 2 alpha plus beta equals minus m. So 2 times minus 3 plus 2 equals minus m. So minus 6 plus 2 equals minus m. Minus 6 plus 2 is minus 4 equals minus m. So m is 4. Oh, that was a long exercise. I hope that made sense.